Thank you very much. It's a great honor to be here. We've seen many wonderful products and, guiding us into the future of IoT. I'm going to talk about 5G and 6G. So we're looking a little bit about 10 years ahead. 6G is going to come in 10 years. And from academia, we're starting to look into what 6G could be. I noticed we talked a lot about IoT, small, low-power devices everywhere. In my presentation, we'll probably go a little bit beyond that because 6G vision really targets new systems that are kind of on the high end, right? So I hope I'm not going to bore you with that. It's not too much ultra low power, but maybe some of these concepts will be interesting to bear in mind for the future as our IoT devices become more capable. So overall, we're starting from this. We are living in a very amazing world in which, communication and access to data is everywhere. And, we can just open our phone and it's available to everybody in the world. And this has really been enabled by two kind of technologies that built on each other. Semiconductor, we can cramp millions or hundreds of millions literally on the space of your thumbnail. So that's an amazing technology that founded the foundation that created the foundation for wireless communication technologies that today allow us to stream exabytes of data in 1 year and make it available to at least half of the world's population. So that's a great starting point. Wireless technology, at least cellular technologies, go through generations, right? And I'm sure you have seen this kind of slide where we started from the second generation to the third generation, going from voice to data access to the fourth generation, bringing us towards video streaming to the device, and now going to 5G. And what's different in 5G from 4G to 3G, 4G, which really were targeted towards providing only higher data rates in lower latencies. In 5G, we're adding new use cases which allow us to expand the market beyond mobile phones because there's only so many people in the world, right? So we need to expand the market further. We need to add devices, and machine-type communication, or IoT, is the field to do that, right? I'm using these two terms, but IoT, I guess, here is a little bit more understood in terms of ultra-low-power devices. Machine-type communication covers a little more devices that are more capable, and maybe in my rest of my presentation, I'm going to maybe appeal a little more towards those, but I hope it's also interesting in this forum. So we're looking at what's the fifth generation. We are adding IoT capabilities, and then as we are going towards the sixth generation, we need to look even further, 10 years ahead. Of course, we didn't need to wait 10 years. The fifth generation is going to evolve in steps, right? Adding massive machine-type communication, but also ultra-low latency. But then the sixth generation, we need to start now thinking what it will be because we need to do a lot of research until we arrive there. And for the moment, that's mostly visions, right? We need to look at it. So what will drive the sixth generation of communication? Well, there are a few killer applications, right? Autonomous mobility will help. Already 5G will help there. And then Industry 4.0, 5.0, and so on as we are progressing, right? Automation, robots, robotics taking part in our daily life. And then also creating an immersive experience for people. Apple just introduced the Vision Pro, right? So all of these ideas come together and they get paired with the idea of autonomous intelligent machines. And that's really the basis for 6G in the context of machine-type communication. In terms of technology, I already mentioned, right, there's semiconductor technology, wireless technology, that's already happening, and now AI is coming, right? Everything needs to be AI, so that's also going to be integrated, and we need to also think of that as we're going to new technologies and envision what will happen in the sixth generation. So here you have a picture of, what people put up when they talk about the sixth generation wireless communication vision. On the left side, we see more the evolutionary part, right? We're going to get better, lower latencies, higher reliability, right? We have already a bunch of nines here after the decimal point in terms of, reliability, available everywhere on Earth, and then, of course, higher data rates on the peak, but also on from a global perspective. But more interesting, so I'm not going to talk about these pieces because it's just an evolution, right? We're just going to get better. There need to be something new, just like IoT was new for 5G. On the right side, you see the picture. I stole this from Huawei, but other companies have similar ideas. So it's a global vision. There are exactly 2 points added to this diagram, which was the 5G triangle, right? Enhanced mobile broadband, ultra reliable communication, machine-type communication. Now there are 2 new dots, the yellow dots, sensing and artificial intelligence. So what do I mean by that? Let's start with the artificial intelligence part. AI is everywhere, right? And AI actually has 2 links to 6G, 5G, 6G. actually, it's usually used as one term, but it's really two kind of concepts. One is to use 6G to use artificial intelligence to help us fulfill the mission of 6G, have greater data rates and more availability and so on. So AI for 6G, right? And then the question is also the other way around, what can 6G do for AI, right? Of course, these concepts are very vague, so I'm just going to illustrate these very quickly in terms of where these points come together. What can artificial intelligence do for the 6th generation? Well, one is in terms of designing these communication systems. The classical approach was we had a model of communication that was based on Shannon and information theory, right, and channel models. These models were simple so that we could well understand them. We could easily understand and model them and then build our receivers to optimally work with these models under the assumption that the models are true. Well, unfortunately, these models had to be simple so that we could build algorithms that would optimally give us optimal performance for these models. And that's how we have worked for the last 40 years. Now we have AI, so we don't need to have a model. We actually learn the world, right? And on the left is the classical approach where, you know, a model tells us what we have and Shannon kind of tells us what we have to build. Now we have artificial intelligence in our transmitter and receiver. We see what we get. Do things work or not? If they don't, we start to adapt. Right, so that's the new approach that is inspired by artificial intelligence. That comes in various aspects. So I'm not going to go through all of this, but that basically helps us to, instead of look at a model and then design for it and hope that it's true, right? Instead of, you know, working with an assumption, we kind of anticipate, we sense, we look at what is the situation and then adapt everything on the fly, and that makes the algorithms of the future more efficient, more effective, and hopefully helps us. We're still a long way from that, and there need to be some balance between what Shannon tells us and what artificial intelligence construction would look like, but that's up for the next 10 years. The other way around, 6G for artificial intelligence. What can 6G do for artificial intelligence? Today, we have all these sensors, and the processing, that the information is processed in the cloud. So the sensors sense, and then they send the information through to the cloud. Maybe the sensors do a little bit of pre-processing. We already see that today, right? So we have some artificial intelligence in the sensor. But most of it gets sent to the cloud, especially for the purpose of learning. And that's a big issue also for privacy concerns, right? You might not want to send all your data, and it also requires bandwidth, right? And then when you want to do inference, when you want to react to the data, you need to send your observation to the cloud. The cloud comes back after running some artificial intelligence algorithm and tells you what to do, right? So this is how things look today. If we want to evolve, we need to build a system where the artificial intelligence is more spread out. It's at the edge in the various sensors. It's distributed, so we're not learning in one central place, and we need to send all our data to one central place where, you know, an eavesdropper could look at it and hurt our privacy concerns. We need to learn in a distributed fashion. So the network of the future needs to be designed to support that, where nodes interact, they gather information in a distributed fashion, they learn in a distributed fashion, exchange only what is necessary between the nodes. So we go away from a cloud-based approach, and 6G is going to, you know, respect these ideas that are still under development today, and that affects kind of the network level. So that was with regards to AI. I also want to touch on another problem that is that also touches on AI, because as we are going to a world that is full of artificial intelligence, we need to gather data, right? So we need to sense, right? We do that already today in our sensor, but data collection is a problem. How do we collect data, right? Well, we can have cameras everywhere, but that may be problematic in terms of our privacy concerns, right? We don't want to put cameras everywhere. We need to stream a lot of data up to the cloud, even from small sensors, and that's problematic, right? So the classical sensing approach, as we have taken it today with having a sensor, a classical sensor, in addition to our wireless communication system, may not be that well suited for the future. It needs to be supplemented by additional technologies. And that was my other yellow bubble that I had in this pyramid of 6G. It's a new idea that has come up. Already it's been around for quite a while, but it's really become a hype in the virtue of looking at the 6th generation of mobile communication. It's called ISAC, or Integrated Sensing and Communication. And the idea is that communication systems typically flood the environment with electromagnetic waves, and these electromagnetic waves get picked up by devices, by base stations, by gateways, and they get looked at and analyzed, right? Now, what the electromagnetic waves do is they probe the environment, right? We can see at this crossing here, right? The red car, receives the signals from other cars, so it knows they are around. Its own signals, they bounce off walls and come back. It can pick them up, and it can say, oh, there's a wall, right? Or it sees the signal from another car with a high Doppler, which means that this car is approaching fast, and can say, oh, somebody is approaching me, right? So we can measure these signals, and we can use communication signals for sensing without adding cameras. Now, unfortunately, the signals that we pick up in this context, we are basically looking through a keyhole. We are seeing the world not through a camera, but through a small waveform or through very few data points. And they are very abstract. They don't show us a picture of the environment. So we need to interpret these communication signals, and that's tricky because they are not a real picture of the environment, right? And here's where AI comes in as a critical building block, because it helps us interpret these signals that we receive that were made for communication and derive something like a picture from it and say, oh, this is actually a car, right? Even though we just get a weird waveform that appears or shows a Doppler spread or some technical property that tells us this car is going to hit us. And this is where we need AI for. So AI and integrated sensing and communication are two things that belong together. Now, what can we do with integrated sensing and communication? Few examples, I think. Really, the limit is, there's no limit to it. You see simple things that are already there today. We can do fall detection, intruder detection. We can measure if a person is trembling, is falling, right, just based on the signal of their mobile phone. So that's amazing, right? We can do people counting. We know this from Corona times, right? When we have too many people in the room, we can tell this from the signal of your cell phone. Not just from counting the number of cell phones in the room, but one person with a cell phone in the room is enough to tell me how many people are there. Right? So that's amazing. We can do a lot of these things already, but more is to be done. It's going to be an integral part of 6G. Now, I'm almost running out of time. I just want to tell you quickly what we do in my lab. We're an interdisciplinary lab looking at cross-layer technologies similar to the lab of Christoph Studer at ETH. We're in Lausanne at EPFL. We're working on systems and algorithms, concepts of 6G, and we're trying also to look at how can we put these systems into hardware, how can we build hardware that uses these algorithms and that realizes them. We're trying to prototype them and put them into integrated circuits. To be a little more specific, 3 examples here very quickly. We look at algorithms. 6th generation systems are typically very complex, so as a small group, we can't build our own 6G modem. So if you want to build a 6G modem, we're probably not the right person to talk to, but we can build the critical building blocks that we need to make these systems happen. There are typically a few difficult blocks, and we know how to build them efficiently and predict how complex they will be. We also try to address the scalability problem, and here I'm coming back to the topic of this conference maybe a little more. We've heard this morning that IoT scalability is an issue. You're adding more and more devices, and at some point the whole system will break down because you've added so many devices that none of them can communicate anymore. So we're trying to address this problem, not at the device level, because the device levels, they are powered on batteries, so we can't do a whole lot. But we can work on the access point, the base station, the infrastructure, and make the infrastructure more smart, so that as we're adding more and more devices and we're scaling the system, it's not breaking down on us. And that's going to be very important as IoT really starts to take off, and we have heard this morning when talking about the MyOT, I believe, and also LoRa and these kind of systems. So we're looking at that. And the third point, we're looking at integrated sensing and communication. 2 examples, localization, of course, obviously very important, outdoor, indoor. That's a great topic. And then also sensing, what you see on the right is kind of a signal. You're picking up the signal from your mobile phone or your watch when you put it on the charger next to your bed, and you want to monitor your breathing. Now, you can't really do that because you've taken off your watch, so you can't measure your heart rate, but the phone keeps sending its Wi-Fi signal, it bounces off your chest, we can pick it up, and we can tell you your breathing rate and everything, if you're sleeping well and all of that. So these are all interesting technologies. If you're interested, I left the link to my lab. Please send me an email. I'll be happy to discuss. Thank you very much.